Hi everyone, my name is Bromann, and today we want to talk about testing complex VS Code extensions. It's an honor to be speaking at SourceCon this year again. I attended and have been speaking at almost all SourceCon, and I love to continue traditions. This time, however, it will be a little bit special because it will be the first talk as a non-Source Labs employee. My desire to build tools for developers has made me move to a company called Stateful, where we are working on improving the lives of developers by boosting their productivity, help them to build sustainable working habits, and allow to take control of their own personal growth. So over the last year or so, I did a lot of research on what productivity means and what focusing means, and I learned a lot about VS Code extensions, because that's the place where developers are. However, as my passion around testing as well as contributing to projects like Whip.io remained strong, I found myself in a position where I could build something that would benefit both ecosystems, which is how I got to this talk in the first place. And don't worry, if you don't use VS Code, nor have you or will you ever build extension for it, this talk might be still something for you, because you will learn a lot about some tricks around automation as well as how you can build a really dynamic page object model framework. So I think we're going to have some fun. Let's dive into it. And let's start with talking about VS Code. I don't know about you, but I've been using all kinds of IDEs in the past. And I wonder who of you remembers the first IDE that they have used. For me, it was some years ago Dreamweaver that I've used to build HTML pages. Then eventually I moved to IDEs like Sublime and switched to Atom, but for the most part of my career, I've been using VS Code as my go-to IDE. And I'm sure I'm not the only one. VS Code has shown to be the most popular IDE right now, according to the State of JS survey from 2020, and many others, including the 2021 Stack Overflow developer survey. There are various reasons for the success of VS Code. For one, it has a large number of extensions, which makes it so flexible. And the way it is architected allows VS Code to stay performant even after installing a lot of extensions as a user. So it is a really nice balance between a simple editor and a blown up IDE. And something that might add to the great performance is the fact that it is built on top of web technologies and leverages web standards whenever possible. This includes web extensions. This includes VS Code extensions as well, which are more or less zipped NPM packages. VS Code is really minimal and intuitive in my taste, and most importantly for me as well is that it is open source. Now, that fact might be debatable. In fact, the VS Code FAQ says that it is more accurate to say that VS Code is built upon open source rather than it is open source. So we need to differentiate a bit here. Because Visual Studio Code as an application itself is a Microsoft product and licensed as such. However, the code that makes VS Code is open source and MIT licensed. So everyone can take the code and create their own IDE from the VS Code repository. So one project that does this is VS Codium that you see on the right. So it takes the open sourced IDE code and bundles them into a vendor neutral application. And it comes without saying that as a vendor neutral application, you remove all the things that are Microsoft related, which are things like app telemetry or the ability to download extensions from the VS Code marketplace. Another project worth highlighting here is the Thea project, which is more an IDE platform. Even though Thea looks like VS Code and uses some of the common components like the Monaco editor, the extension model, the language server protocol, it provides more like a modular architecture for you as developer with a single open source technology stack, and provides you more capabilities to create a customized IDE. It can be seen as a base layer for adopters to develop a custom desktop or cloud IDE. And it has been used in projects like the Google Cloud Shell or the Arduino IDE version 2. Both VS Codium and Thea support VS Code extensions though. And as I mentioned before, the VS Code marketplace it only accepts Microsoft projects. So those projects need to have a different kind of marketplace, a vendor-neutral marketplace. And here's where the Eclipse Foundation comes in. They run a project called the OpenVSX Registry, which is like the VS Code Marketplace, a registry to host extensions that use the VS Code APIs. But while only Microsoft products can use the Visual Studio Marketplace, anyone can use the OpenVSX Registry to distribute their extensions. And anyone can access and download it from them. So Thea-based IDEs, VS Codium, and even VS Code itself can use the OpenVSX registry. The marketplace is basically just an integration detail for an IDE. And both registries have about the same amount of extensions available, but not every extension is registered in one versus the other. So, but given that publishing an extension in either of these platforms is almost the same command, many extension developers started publishing to both. Now, why do I tell you all of this? The ecosystem around IDEs has been growing a lot. And the way we use IDEs today, I believe, will be completely different tomorrow. We already see the trend towards ephemeral workspaces in the cloud, GitHub Codespaces, for instance. And we also see the impact that extensions have on the developer workflow. They've become much more than just a simple set of code snippets or suggestions. They play an integral role in the way how developers will do their job in the future. And they're getting more and more complex. And the ecosystem around it is growing and growing. For example, we have GitHub Copilot, what you see on the left here. It is an VS Code extension that writes code for you based on machine learning algorithm. It is powered by OpenAI Codex, which is a new AI system created by OpenAI. And it is trained on a selection on the English language and source code from publicly available sources, including public repositories on GitHub. Another great example is the Crocker extension for VS Code. This is one of the few extensions that aren't open source and where you need to acquire a license to be able to use it. Once you acquire that license, it provides a tremendous value for you as a developer, and it kind of changes the way you build applications. So you see that extensions are more and more helping you to do tasks in a more automated way and avoid things like context switching, which limits your capability to stay focused. One extension that helps you to reduce context switches as well is an extension that I've been working on called Marquee. It is one of the first extensions that brings you a full extensible home screen with various widgets into your VS Code application, where you can do things like managing to-dos, snippets, or notes, get weather information or read the latest hacker news, or just manage your workspaces to be able to switch back and forth really easily. To achieve this, Marquee depends heavily on web views within VS Code, and it interacts with various components of it. And it has rather a complex and difficult state management and configuration management, and it even allows other VS Code extensions to contribute widgets to the home screen. All these examples show how much complex extension has become and will become in the future. And like other complex software, those need some special testing requirements. Well, at the end of the day, an extension, as well as VS Code, is basically just a web application. These web applications need to adhere to the APIs its runtime offers, which is ultimately the web API, or in the extension case, the VS Code API. And as these extensions are getting more and more complex and are able to be used in more and more environment that might differ in one way or the other, we need to have the ability to test beyond the unit test level. So what can we do to test VS Code extension? The basics, let's understand first how an extension looks like. The basics of an extension is really simple explained. An extension is more or less a node package with a package JSON. Within that package JSON, we define some capabilities, what this extension contributes to the IDE, as well as a pointer to a file, which is our entry file. That entry file exports an activate method, which then, has the context to register objects for the IDE on, and has the ability to import the VSCode API and use it to attach, elements and components to the IDE, and to make the extension basically work. So the most basic Hello World example you see here on the right, and from there you can build up your extension using the API as documented on the left. So far, so good. So how are we going to go about testing this? The way it is currently recommended by Microsoft is to use the VS Code test electron or test web packages. Both help you to start specific VS Code flavors, either a native application or the browser to test web extensions. And they allow you to run your test suite as an extension, which provides you access to the VS Code API. And many extension developers use this approach to run their unit and integration test. Now, writing unit tests doesn't much differ from other applications. Integration testing, however, is a little bit more interesting. Here, the goal is to use the VS Code API to trigger certain events or commands, and then evaluate it with your extension. So let's say we take the prettier extension that many of you might be using, and let's say we want to test if the prettier extension formats our code correctly. So I've been looking into their test code, and what they do is essentially they insert some text in the editor, and then they trigger a VS Code command to format the editor. And at the end, they will read the text from the editor and compare it and check if the text is formatted correctly. So the VS Code API is quite exhausted and allows for some degree of automation. However, you can do things like open or reading the editor content, but it certainly lacks in some way or another in end-to-end testing capabilities. Remember the Marquee app? It is really not possible to test the web view inside the VS Code extension with just the VS Code API. But before we went into what we need to test, let's dive into some testing fundamentals first. Whatever we do, we need to be careful about how we are testing things, and I'm sure we all know by heart now the concept about the testing pyramid by Martin Fowler. You do a lot of unit tests, those are cheap and effective, and then run some service tests to ensure the compatibility between components. And lastly, you have a small set of UI tests that run everything from end to end. Now, Kenzie Dotz has introduced the testing trophy, which puts the focus more on the integration test. His argument was that the testing pyramid makes sense when the assumption is that high-level, broad stack, or end-to-end tests are expensive, slow, and brittle. If this is not true, we can move the majority of tests further up the pyramid because they are more valuable. I say the same is true for VS Code extensions, where you still need a decent amount of linting and unit tests. It makes totally sense to cover the important use cases with end-to-end tests as well. Especially if we think about that VS Code tests usually run directly with Chrome driver and can be run in any CI these days. And also, if we build a really a dynamic page object framework, everyone can use that page object framework because VS Code is wrapped in one application where we can build a page object model around it. And everyone can contribute to that framework to make it really solid and non-flaky. But running end-to-end tests especially makes sense when the extension leverages a lot of web views in VS Code, like Marquee does. The web view for Marquee, at least, the most application code resides can only run within the VS Code environment. And the VS Code app is not the only environment it can run in. It could run in VS Codium or in Thea-based IDEs. So it's worth to write end-to-end tests for it to make sure that all these use cases are covered. And but at the end of the day, we still need to be deliberate about how and what we're going to test in our application. So we would definitely want to know if our extension even loads, if our widgets within Marquee persist the user input, or if changes in the web view, for instance, are reflected in the tree viewer panel on the left. Those are things that we might to cover because they connect application code with things that run with the VSCode API. Other things, however, like clicking a save button would trigger a file model. Those are things that we don't really need to test because they are more really testing the VSCode API, which is already tested a lot. So there are some things that we don't need to test because those are encapsulated in the VSCode API, but there are some things where it makes sense where we want to check if everything works from end to end. So as a WebDriver contributor, I know that WebDriver can automate browsers, mobile phones, heck, even TV devices and native Electron apps. So I thought, well, for sure it can also test VS Code extensions. For people who don't know what WebDriver is, WebDriver is an independent implementation of the WebDriver protocol, and it allows to automate everything from React, Svelte, Vue, or any kind of browser apps, including mobile browser apps or even native mobile applications. And again, even TV apps or Electron applications. It is extendable through various reporters or services. And so for testing VS Code extension, I've built a service that will allow to do exactly that. And on the journey to build that service, I've been facing some interesting challenges that are particularly to VS Code. The challenge that VS Code applications have is that it comes with various flavors. As I mentioned before, you can run VS Code not only on your desktop, but you can run VS Code in the browser. So there are some differences in the details here that you might want to cover as an extension developer. Also really tricky is that VS Code is a continuous changing application. So there are new versions coming out every month or so, and the VS Code team might decide to change certain selectors within VS Code, which then can break your end-to-end test selectors. So you need to build something that allows you to cover for that and allows you to test your VS Code extension in various versions of VS Code itself. And lastly, we need to build a framework that allows all extension developers to leverage a page object model so that they can just automate VS Code without having to inspect the whole application themselves. Let's resolve the first challenge. VS Code can be used as an Electron app. As you all know, it is based on Electron, or through the browser. The good thing about easy thing about that is that both can be automated through Chrome driver. That is good. However, there are some tricky details here. So the Chromium, which is bundled with Electron, differs based on which VS Code version you are using and which Electron version is bundled with that. So in order to seamlessly automate that Chromium, you also need a specific Chrome driver version to it. So there are some setup challenges here where you need to understand which VS Code version you have, which Electron is bundled with that, and which Chromium version it is using to then be able to download the right Chrome driver version and go ahead with testing. A little bit more tricky is the fact that Chromium only understands flags with a minus, like minus remote debugging, remote debugging port. So therefore, Chrome driver doesn't really understand other kinds of flags that are written in the camel case format, for instance. So for some reason, Chrome driver here will lowercase all these parameters, and that leads to the fact that VS Code will not understand the flags like the extension development path, as you see there, which is an important flag to point VS Code to your extension that you want to test. One way to work around this here is to build a proxy binary that is able to transform these flags back into minus separated flags in order for VSCode and Chromium be able to read those flags. And then when it comes to testing web extensions in the browser, there are some difficulties setting up a web server that would allow to serve VSCode properly. There are some details here where you cannot just start a static server and serve the front-end code of VSCode. That wouldn't work. Another challenge is that VSCode is an always continuous changing application. But compared to your always changing application, where you only have one version that all customers are using, VSCode, not all VSCode users always update their VSCode version. So it has been a problem for extension developers like Don here, who said, whenever VSCode UI changes, the CSS queries have to be updated every time with every release. Those we had to end up with one set of tests working for stable and not insiders unless the CSS queries are updated. So while not all selectors really change in every release, it happens every once in a while. And one way to address this problem is by working with page objects. But here the detail is that you want to separate your selectors into a locator map and separate them from the actual logic of the page object. So whenever a selector changes, you only have to update the selector map rather than the whole page object. Let's see how this looks like in details and how we can build a really dynamic page object framework. So for VS Code, what you could do is to create a page object for every component in the workbench and define locator maps for each one of them. So you have a locator map for the activity bar, for the status bar, for the sidebar, and so on. And then you create files for every VS Code version that contains your selectors. And if one selector changes in a new version, you create a selector map for that specific version that imports the predefined locators of the previous versions and overwrites them. And later, you will have a utility function that will give you the locator map for your specific version. This idea actually originates from some smart folks over at Red Hat who have built this kind of page object model with using the Selenium framework. With that, we need to design this page object to ensure that that we transform the selectors into the selector maps into WebDriver elements, that we have a base element that is optionally definable or can be received from the locator map directly. We want to have the ability to parameterize these selectors. We want to make these page objects not immutable, so no one can change the behavior of those page objects. We want to make sure that when we query elements, we scope it to that main page object element. Of course, we are in 2022. We want to have TypeScript support, and we want to auto-generate some documentation around our page objects. And the way a page object can look like is, as you see in this example here, you have a locator map, and that locator map you feed into your page object to then write your functionality around it. Let's start with to solve some of these design goals. First off, we want to transform the selectors into WebDriver elements and make sure that they are scoped to the base element. And the way we do this here is that we use decorators. These decorators, which currently needs to be transfiled by TypeScript or Babel or whatever you have, because it's not yet native to JavaScript, but it will become eventually. They have to be set in the front of all page objects. And what they do is they run the code before the instance is being created and access the locator map and create some dynamic getters for your prototype. And so every time you call your locator key with a $sign or the $sign at the end, it runs the specific code in the decorator and returns you the WebDriver element as a chainable element, so you can continue calling certain commands to it. Now, in order to parameterize these selectors, what we now can do is to check whether the selector itself is a string or a function. And if it is a function, we return a function itself and use the result use the result as a query for our selector. As you can see here, again, we always call this element $$ or this element $$, which means that we always start looking from the base element of the component and never outside our actual page object, which makes sure that we have reliable query results. And lastly, one nifty trick is to make your constructor immutable. This prevents any attempt of any of your colleagues and developers to kind of change the behavior of a page object in one of your tests and then be confused why your page object doesn't work as expected. So it's not really a page object feature, but more a general guardrail. Next you can see is the base page. As you can see, the constructor will always expect a locator map to make sure that all our page objects use the right locator map for the specific VSCode function version. And it allows you to pass in a base element, and if the base element is, if you don't pass in the base element, it tries to find the element from the locator map as well. And if it doesn't find any of those, it just queries based on the HTML tag, like from the global point. You can see you can check out the VSCode, the WDIO VSCode service, and check out the whole page object design there and copy it for yourself. Lastly, in order to be able to have proper TypeScript support, we need to apply some TypeScript voodoo here to ensure that the elements that the getters that we assign to the constructor in our decorator are seen by TypeScript, because TypeScript doesn't automatically understand this. And lastly, we want to have some documentation around our page objects. And luckily, thanks to TypeScript's documenting character, we can use tools like TypeDoc that generates us an HTML page with all documentation, methods, and elements of our page objects. Enough talked. Let's dive into our little demo here that I've prepared. So I contributed end-to-end tests to the VSCode Live Server extension. That extension basically allows you to click on this little Go Live button here, which then starts a server in order for the browser to access your workspace and, for instance, show the HTML code that you're working on. So we want to test that. And so our test, what it does here is essentially it uses the page objects that comes with the WDIO service. And it first off removes all the notification, because VS Code has a little thing where it can suppress some new notification if there are too many notifications going on. So we remove all notification in the beginning. Then we click on this little live server button here at the bottom, and we read the port of the server that is being started from the notification. And lastly, we use a new browser, like a second browser, to open that server, the server port, and see if we can access those files. So I've added some pause here to make sure that we all see what's going on. So let me run this. So it starts VS Code, and then it starts a browser, which I'm gonna move in a second. There we go. So now we see that we're going to click in the button on the Go Live button. There we go. Then we read the port, and then we use the browser to access the port, see if all the files are available, and then it actually serves other files. And there we go. With a simple test, we basically tested the extension from end to end. With that, I want to thank you all for listening to my talk. I hope it was enjoyable, and enjoy the rest of SourceCon. See you later. Bye bye.